Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking IBM for sponsoring today's event. IBM has become a strong supporter of the Data Science Central community, and we are honored to have them sponsoring our webinar today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Pivotal, Microsoft, Hortonworks, Oracle, Tableau, and Teradata, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled From Insight to Action, Predictive and Prescriptive Analytics from IBM. And before we begin today's webinar, I'd like to just briefly review the format for today's event. Today's webinar will be approximately 1 hour long. We have a single panelist that I'll introduce to everybody in just a few moments. We should have between 10 and 15 minutes for Q&A following the presentation, and this event is being taped and will be made available later on this afternoon at datasciencecentral.com. I'd also like to encourage the attendees to provide questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Matteson. I'm one of the co-founders of Data Science Central, and I'll be your host for today's event. Joining us today for the Q&A portion of today's webinar is Bill Voorhees. He is a contributing editor at Data Science Central, and we are thrilled to have Bill helping us out with today's webinar. I'm very pleased to introduce today's speaker, Mikhail Lakirovich of IBM. Mikhail is a product marketing manager at IBM, where he focuses on developing and executing go-to-market strategies for predictive analytics and decision optimization. He holds an MBA from the University of Chicago and is currently pursuing a Master's of Science in Predictive Analytics Computational Methods. Thanks for being with us this morning, Mikhail. We're looking forward to your presentation. Predictive analytics has become an imperative for organizations as they strive to incorporate data-driven decision-making into their processes by understanding potential future outcomes. Prescriptive analytics can then be built on this foundation by answering the eternal question, what should we do about this? In today's webinar, you will learn how IBM SPSS Predictive Analytics can help you uncover patterns and trends in your data, and how IBM Decision Optimization can be leveraged to incorporate those insights into optimal decisions, and how IBM Analytics lets you understand your data with ease and speed to translate that understanding into value. Before we begin the presentation, I pass it off to Mikhail. We have a few poll questions that I'd like to ask our audience to participate within. These are always great to get a sense of who's with us today. So the first one is, what are the most common techniques that you use? Is it regression, logistic regression, decision trees, clustering, association rules, neutral networks, and finally, if none of these apply, just click none of the above. So just mark the selection that most is appropriate for you. I'll give everybody a moment, then I'm going to advance the slide, so we'll see. So here we go. Thank you for participating, everybody. It's always interesting to see these results on real time. So the next question is, what would you like to do that you're not doing now? Is it more advanced techniques, big data, visualization, or again, none of the above? If you can just make a quick selection, we'll move to the next one. Here we go. Thanks again. And then the final question before we get going here is, what issues or concerns do you have with your current tool of choice? Is there a steep learning curve? Is there limited functionality? Does it require a deep statistical computer science knowledge to be effective? Or if, again, none of these apply, just select that button. So please make a selection, and then I'm going to advance it. There we go. Always interesting again. So with that, I'm going to turn the presentation over to Mikhail, and you can get going as soon as you're ready to go.
Thank you, Tim, so much for, first of all, having us, having IBM and having me speak to the audience today at Data Science Central. And so before we begin, I just wanted to, I was sitting kind of in the shadows looking at the results of the survey, so I just wanted to, kind of comment on what I saw. And it was really interesting to see that, regression looks like still is a top, a most commonly used tool, not surprisingly, especially for dealing with predicting outcomes that are, quantifiable versus discrete versus predicting, X, Y, or Z. Are we going to do this or are we going to do that? Is a person going to churn, a person not going to churn? So that's interesting to see. And that kind of also ties in, I think, to the other response that looks like the majority of the audience is looking to take advantage of more advanced analytical methods that may go beyond regression, that may go beyond, the more simpler classification algorithms. And that also, I think, really ties in well to the other response of that I saw that one of the key issues or critical imperatives is to have first have to deal with a steep learning curve when it comes to implementing these techniques, and two, having a deep statistical knowledge to do that. And I think this will really tie in well about what we're going to talk about today, specifically around predictive analytics with SPSS Modeler and Decision Optimization. So, as we, before we begin, I have to give my obligatory kind of spiel about predictive analytics. So from a technical perspective, predictive analytics encompasses analytical techniques drawn from stats, from data mining, game theory, many more. And these techniques are used to uncover, as Tim has mentioned, hidden insights and relationships in your data. So why has something happened? What is likely to happen next? These are the key questions that predictive analytics helps answer. And predictive analytics lets the data tell its own story. So you can choose to direct the story. You can let the techniques find the story for you. And this technique, predictive analytics, can anticipate a future state. So we can talk about the kind of questions it can answer, and the predictions of this future state can be tempered with a measure of confidence. And so sometimes the future, is very clear, sometimes it's not as clear. So predictive analytics can differentiate between those scenarios and place that bandwidth, the band of confidence on the predictions. And using the predictive intelligence to inform decisions leads to better outcomes, which we see time and again across tons of organizations that are using predictive analytics across a variety of industries, disciplines, organizational functions. So really this is a data agnostic, it's industry agnostic, it's a function agnostic discipline, and the benefits that can be derived from predictive analytics are applicable across the entire organization. So for marketing, how do you acquire, grow, and retain your customers, and how do you prevent them from leaving your organization? How do you maximize the value of those customers to your organization and maintain a good customer relationship, client relationship? When you're looking at finance, how do you transform financial processes? How do you manage risk? If you're in operations, how do you optimize your operations? How do you detect and prevent fraud? How can you tell if a transaction is fraudulent or if a transaction is okay? And the fact is that analytics drive success for organizations and are an integral part of decision-making process. And in fact, right now, according to a recent IBM study, 7 in 10 leaders agree with that. And the investment into analytics will continue to grow and become more significant with time. So I want to quickly touch on a customer story from C Spire Wireless and mention a nice quote from the manager of brand platforms and analytics from the company. And I want to share that with you. The quote is, "We're not only getting a more complete picture of our customers' needs, we're translating those insights into a higher value customer experience that increases their satisfaction, strengthens their loyalty." So to be successful, the company needed to beat competition on things that really matter, such as getting close to customers and keeping them satisfied. And its challenge was to convert what it knows about customers into actionable insights that help account reps craft optimal offers that meet the needs and head off, customer dissatisfaction. And the company is using predictive models to look through the complexity of the customer's behavior to determine which service mix is optimal for each customer's need, as well as see what the indicators are of imminent churn to be able to proactively prevent that. And by embedding these insights into customer-facing processes, C-Spire Wireless empowered its reps to optimize their interactions with customers. And the most fundamental benefit of the new solution is its transformational impact on the quality of customer experience. Because sales reps, have insights into the overall customer relationship, augmented by the power of predictive analytics to model broader customer activities and trends, they can make recommendations that resonate with the customer's needs. So that means not only a larger revenue stream per customer, but also a stronger relationship and lower probability of churn down the road. So there were real business results from this exercise: improved effectiveness of customer retention campaigns by 50%, increased cross-selling and upselling efficiency by offering optimized product and service bundles, boosted customer satisfaction through the enablement of a more personalized customer experience. And we'll return to this story and to C-Spire a couple of times throughout the presentation. So what I want to do now is just quickly touch upon the analytics journey, the path an organization takes to transforming data to information, to knowledge, to action. And this journey can be broadly divided into 3 stages, and our conversation will be focusing on the latter 2 of them. So the first one is descriptive analytics. It provides tools to look at the data, look at aggregates, be able to query and drill down, really business intelligence. So for example, let's take a look, if we're talking about like a regional bank manager, and they want to see revenues per region, per month, per main market segment. And the bank manager may also want to be able to, drill down geographically by product category, understand what products generate what revenue, how different offers fare by bank branch. And descriptive analytics helps understand what happened so far. So predictive analytics, it's about understanding and analyzing data. Again, includes statistics, machine learning, data mining. It's used to detect trends in revenues and customer behavior at the bank branch, to uncover information that is not available, that is hidden. So for example, again, based on historical behavior, the bank can understand what offers which customers are likely to respond to. So maybe one customer is likely to respond to a promotional rate on CDs, another customer may respond better to cash bonuses, etc. And also understanding which of these customers are likely to churn. So what is it about these customers that makes them more susceptible to churn, makes them more likely to leave your bank, so you can prevent that before it happens. And predictive analytics, as Tim has said, helps understand why things happened and what is likely to happen next. So the next step, prescriptive analytics, that's about making decisions and recommending actions. This is where mathematical optimization plays. So for instance, operations research at this bank will use optimization to determine what offers are best suited for which customers. And prescriptive analytics helps us to decide, so what do we do next? What do we do about the future state that we've predicted with predictive analytics? So let's get started with predictive analytics. So when we're looking at predictive analytics, we can think of 2 core approaches: statistical analysis and data mining. Both of these drive predictive analytics, and both are needed. Both are important. Statistical analysis takes a top-down approach. So a theory is formulated about what is happening in the data. The statistical procedures allow the user to test the theory, find confirmation for it and findings, and then the findings are summarized for other stakeholders. Data mining takes a bottom-up approach. So users are exploring data for patterns using algorithms that involve multiple statistical procedures to confidently predict the future. So as a result, there is a model that can be deployed. So the logic of the drivers is now encapsulated and can be used to automate a process intelligently to provide a person with a recommendation or much more. So with that, with this picture in mind, let's talk briefly about IBM's core predictive analytics product, SPSS Statistics, which takes the top-down approach, and SPSS Modeler, which takes the bottom-up data mining approach. So IBM SPSS Statistics is a software that is used by a variety of customers to solve industry-specific business issues to drive quality decision-making. If you've taken a statistics class at university and graduate school, chances are you have used IBM SPSS Statistics. And maybe some of you in the audience saw the webinar on Data Science Central. It was on May 26th, 7 reasons to combine SPSS Statistics and R. So for those of you who haven't, it definitely encourage you to listen to the webinar. It has a lot of interesting information. Talks about the integration between SPSS Statistics and open source R. So SPSS Statistics, provides a really comprehensive set of tools for the entire analysis lifecycle, customizable with multiple data types and add-on modules to give people really what they need. So you can access functions through different interfaces. You can have a command line syntax if you want, or you can have extensibility for more experienced statistician, but then you also can have this menu-driven experience for someone who's more of a business analyst or someone who's more getting started with analytics and necessarily doesn't know how to script. So statistics also allows for multiple deployment options, from a standalone desktop application that's good for individuals to a multi-client server deployment that's appropriate for larger analyst teams. SPSS Statistics also, helps quickly understand large and complex data sets, that you use advanced statistical procedures, that you end up with high accuracy to drive quality decision making, and it helps reveal deeper insights and provide better confidence intervals through some visualizations and now also geospatial analysis. And again, as I mentioned, the webinar that took place on May 26th, it has programmability and extensibility, so advanced users can take advantage of common scripting languages such as Python and R, as was the topic of the last webcast. May 26th. So using SPSS Statistics, you can process and deploy analytics faster with really flexible deployment options. So you're looking at here is the modeling, the SPSS Modeler workbench. And Modeler is a comprehensive predictive analytics platform designed to bring predictive intelligence to decisions made by individuals, groups, systems, and the enterprise. And Modeler scales from desktop deployments to integration with operational systems, providing a range of advanced analytics, including text analytics and entity analytics and social network analysis, decision management, optimization. And Modeler is built with the business user in mind. Marketers, service analysts, and more use Modeler today, and Modeler is recognized for its ease by industry analysts and users alike. So, one of the critical questions or concerns that we saw in the polls today were, the need, the steep learning curve and the need to really have a deep statistical knowledge. Well, Modeler allows you as a user to overcome those hurdles, overcome those barriers, and increase the time to value by using Modeler. So, at the same time, there is sophistication for those who want to take advantage of it. So the expert users can take advantage of it again through scripting, through advanced features. There's a wide range of data manipulation, analytical algorithms available, everything from market basket analysis through recency, frequency, monetary value analysis, through geospatial analysis, entity analysis, and much more. And again, flexible deployment options mean that this environment can grow with you, scaling from a single user to desktop through an enterprise multi-client, again, deployment, as well as a deployment on the cloud. So this visual summarizes the relationship between statistics and data mining and what each provides to the analytical process. To reiterate the point, both products support the process of predictive analytics, and the synergies between them provide the biggest value to users. SPSS Modeler can be used for data mining to uncover new insights, and SPSS Statistics can be used to validate predictive models, form hypotheses, and analyze the data. And in fact, so the company that we earlier discussed, CSpire, capitalized on this synergy and deployed SPSS Statistics software to analyze the data and SPSS Modeler software to develop predictive models that can help pinpoint the early indicators of customer churn. So what we're talking about, the next step is going from predictive to prescriptive analytics. So we're going from what is likely to happen to what should happen to what should we do about it. How do I react to potential inventory outages? What campaigns should I use to promote items that are likely to interest potential customers? When will my equipment be likely to break down? How do I conduct preventive maintenance to minimize the chances of that occurring and resulting in capital expenditures? And this is the thought process that we really want to highlight here. Predictive analytics tells me what is likely to happen next, and prescriptive analytics tells me how to act based on what I know, what is likely to happen, and based on the constraints I have around my business. So returning again to CSpire, I promise we're going to do that a couple of times. The solution's decision optimizations capability that they used made it an ideal platform for guiding reps in their cross-selling and upselling activities. So it begins with a comprehensive view of the customer relationship, from calling activity to accessory purchasing history. And when a customer calls in to the contact center, walks in one of the retail stores, the solution draws from the customer's data to determine what combination of products and services would best complement the customer's existing service profile and present it to the rep as an on-screen scripted recommendation near real time. And because such recommendations are based on solid insights from predictive analytics, reps are more likely to succeed in their cross-selling or upselling efforts, while customers are more likely to come away with a more satisfying experience. So before we go into prescriptive analytics and talk about decision optimization, I wanted for us to quickly jump into SPSS Modeler for a quick look around this workbench and see what it can do for us. So just bear with me. So what we're looking here again is the Modeler workbench, except now we're live in it, and this is what it looks like. This is the white screen in front of you is the canvas. This is where you would be building the modeling stream. And as you can see, the modeling stream is built in a very intuitive, easy to understand manner. So you start with your data, you pre-process the data, you apply an algorithm or a data mining technique to it, and as a result you have an output table that you can then, or a file that you can load into any type of sources. So let's quickly go through this bottom palette with the nodes. So what these are called are nodes. So there is a number of different source nodes that we can take advantage of. So you can pull data from HDFS, you can pull data from databases, flat files, you can export data out of from Cognos if you have Cognos. So really a variety of data sources that can come through. Right here, the record operations. This is where you can select data, you can sort your data. If you have an unbalanced data set, you can take care of that and balance it out. You can aggregate data from multiple sources. You can merge data from different sources and append one data set to another data set. Right here, the field operations. This is where you can do some automatic data preprocessing, identify, select which variable in your data is the one we're going to predict, which one is going to be the predictor, which ones are not relevant, filter out some variables, reclassify one into another, derive a new variable, etc. Right here we have some graphing capabilities, and really right here what you're seeing is all the different types of algorithms that you can take advantage of with SPSS Modeler. So when it comes to classification, if you're predicting numeric outcome, you have regression. If you're predicting categorical outcome, you have logistic regression, you have k-nearest neighbors, you have different types of decision trees, you have neural networks, you have Cox regression. So you have all kinds of different models available for you if you're doing association rules, if you're doing a segmentation, all kinds of different algorithms available for you. So that can be overwhelming. What's really nice about Modeler, what you see right here, you have auto nodes. So these nodes will let Modeler select the best model for you, given the data type you have and given what you're trying to predict. And then, we can do some outputs, so we can analyze our data, export it into matrix or table, do an audit on the data, and, we can export it again back into multiples of, anywhere you want. You pull it out from, you can put it back in. So what we're looking here right now, the stream that we're looking right here at, this has been taken out from Kaggle, and which is an online site for data science competitions. So this data set is talking about the Titanic case. And for those who know about the Titanic, this is really where the women and children first really was used, the fact that women and children were much more likely to survive. But again, this data set under the Kaggle competition helps us, kind of understand how predictive analytics works, how data mining works, and how classification algorithms work by determining who is and who is not likely to survive. So we have two streams right now. The first stream at the top, this is the training stream. So this is the one we're going to use to train our data, and then at the bottom, we're then going to test it out. So right now we have some data loaded, and as we can see, this is our data, and we see that we have some null values for age, so this is something we'll have to take care of a little later. Then if we go into the type node, we can designate the survived. This is where we're trying to predict who is and who is not likely to survive as our target variable. We can, filter out some variables we won't need, like a name. It's not going to be a name. It's not going to be a good predictor of any sort of outcome. And from there, we can do a quick data audit. So what this will do for us, it will give us a quick summary of descriptive statistics for our variables. What also is really interesting and neat is then we can go into the quality tab. We'll see that we saw a missing value for age. So if we look at age, we see that about 20% of the age values are missing. So if we go ahead without taking care of that, our analysis is not going to be as robust. So what Modeler lets us do is impute these missing values. So impute them with an algorithm. And when we click the missing values supernode, this star appears, and this star inside of it is the CART algorithm, so classification and regression tree, decision tree that will allow us to impute the age for the missing passengers. So again, I mentioned for those who are just starting out with predictive analytics, or for those who are not sure what type of algorithm to use, should I use logistic regression, or should I use neural networks, or should I use shade decision tree, or should I use a CART? Modeler allows us to pick out the best model for the data. So what we do right here, we select this algorithm, and we want to have 3 models. That's what we do, and we'll click Run, which we already have, and this gold nugget appears. And this gold nugget, this is the actual model. So when we look at it, Modeler has selected 3 algorithms for us that seem to do the best job at classifying the outcomes for our trained data. So the C5 algorithm, the neural net, and the shade. So let's take a look at the C5, as it has the best accuracy. So if we go into the viewer, what we see is the decision tree on how our data is classified. So very easily, that's the nice thing about decision trees. They're really consumable and easy to understand, especially if they don't grow too large. So what we see right now, the probability of survival. Again, we talked about women and children first. Well, if you're a male, your probability of chance of survival not too great as compared to if you're a female. And then, not surprisingly, women and children. The next thing, if you're a male, the age is then used as the next variable to split the data. So if you're young, if you're a child, if you're a female, if you're in higher passenger class, you're much more likely to survive. So passenger class 1 or 2. So again, this is not surprising. We've seen the Titanic movie with Leonardo DiCaprio, so not too a surprising outcome, but still a nice way to see how it works. And then what we do is we can then use the same gold nugget, the same model, to run our test data through. And we'll have an outcome. So we have a test data set with passengers, with information on them. And Modeler is going to give us the predicted outcome, survive or didn't survive, and the probability of that outcome. And then we can take this output and then we can push it out into, for visualization back into our database. Or, for example, if we're looking to do decision optimization into the decision optimization tool that will consume SPSS Modeler outputs. Because if you think about it, let's say we have 100 passengers surviving, but we know that we only have so many lifeboats, and we have such only limited utilization capacity on each of the lifeboats. So just because we've predicted 100 passengers to survive, given the real life circumstances, maybe only 80, 90 of them would be able to survive. So how do we actually capitalize on our assets to make sure that the most number of people survive? So, and this is where really decision optimization comes in, and that's what I'd like to discuss next. So this is the piece of the puzzle that takes predictive analytics and turns them into recommendations, which is what prescriptive analytics is. And for those, if there are any history buffs on the webcast right now, optimization made its debut during World War II when scientists determined ways to make efficient use of limited technologies and resources. And optimization is, it's a mathematical discipline that's focused on efficiency, and it's really frequently used in the world of business. Applies math and logic to the pursuit of objective efficiency. It takes facts such as costs, yield, available resources, and demand, goals, and constraints, and finds the best possible plan or course of action using mathematics and logic. And optimization helps businesses make complex decisions and trade-offs about limited resources. Discover previously unknown options or approaches, automatically evaluate millions of choices, explore more scenarios and alternatives, understand sensitivities to various challenges, and gain insights into input data. So what are some of the use cases where predictive analytics integration with decision optimization can prove its value? So, for example, price optimization. So how do you maximize your overall revenues by selecting the optimal price? So normally, if a price of a good goes up, the quantity of demand will decrease. Just a basic law of economics for normal goods, unless we're talking about those goods that only increase in value when the demand for them increases with the increase in price. 7-star hotels somewhere that I've never been to. Sophisticated, price optimization solutions will utilize complex mathematical formulas and concepts and will help organizations determine that point where the right price and product mix results in maximizing their revenues. So you can integrate your predictive model outputs for price and product mix with optimization to create prescriptive analytics, helping you decide what you should do based on likely event outcomes. When you talk about finance and investment portfolio optimization, controlling transaction cost is critical in implementing profitable portfolio trading strategies. And optimization models can identify opportunities to group trades across multiple portfolios to take advantage of discounts or execute internal trades. The ability to manage large numbers of trades automatically through an optimization application really provides that basis for effective operational cost control. Nurse scheduling optimization, or for that matter, any kind of workforce scheduling. So for example, you need to schedule staff for a large operating room environment at a major hospital, and there's 40 individual operating rooms that are scheduled 12 hours a day, and over 350 people scheduled in a month to do all kinds of different jobs. And some are credentialed nurses, some are other less broadly trained people, some RNs, some not. Many of the nurses have certain specific specializations in clinical areas or procedures. Then you have surgeons that are assigned operating rooms and block times that don't necessarily align with staff shifts. So then the schedule is a monthly schedule. You have to post it a month in advance, although you can make adjustments afterwards. So you have a lot of different conflicting interests and conflicting goals, and the goal of this optimization here would be to minimize labor cost while satisfying multiple constraints, and this is where optimization really shines. And then logistics and route optimization. How do you optimize the routes for your drivers, for your trucks? This is again where optimization comes in, and it's not limited here. There's all kinds of different use cases. And an optimization model, is a really it's a carefully defined set of inputs. You have demand, and resources, and costs, assumptions, constraints, preferences, goals that are expressed in equations and matrices and logical statements that help you find the best solution to a business planning or scheduling problem. The output will be like an optimized plan or schedule with information about the best possible solution, with binding constraints and underlying economics and operational efficiency. So when all these components, put together into a optimization model and executed using optimization engine, the result then is the best possible plan or best possible schedule or set of schedules to achieve a goal or set of goals. So for example, a final output could be a supply chain network design, a multi-year production plan, a detailed production schedule, a workforce schedule, set of routes, set of trades, set of price offers, everything we've discussed and much more. So now let's go through a use case of an organization doing a marketing campaign. And in the very beginning of the webcast, we just gave some examples. We'll have bank branch. So let's stick with that, and let's stick with this example and continue with this bank story. So continuing with it, for a bank, let's begin with identifying our business problem at hand. So the bank is looking to develop a marketing plan that will maximize revenues. And we have certain products to offer the customers, and we have data on our customers, such as their demographic and financial data. And the company has a historic data tracking on the offers that they made to customers in past campaigns, as well as the responses to those offers. And the result of our model will be 2 potential offers, product offers per customer, and confidence levels for customers accepting each offer. So now we can move into decision optimization part. We're moving into the real world where resources are constrained, and where we have to make frequent trade-offs in our decisions. So just because an action may be good doesn't mean necessarily that we'll be taking that action. So in our case, unfortunately, due to the bank situation, it can only offer one product to a customer, and we have to be sure to stay within budgets and allocate offers among products. So our goal is to balance all these constraints, to select those offers to such customers as to get the highest possible return. So for the predictive piece, we'll be using a self-learning response model. It's one of the algorithms in SPSS Modeler that we just saw. It enables you to build a model that you can continually update or re-estimate as the data set grows without having to rebuild it every time using a complete data set. So for example, this is useful when you have several products and you want to identify which product a customer is most likely to buy if you offer it to them, as we are in our case right here. So this model allows you to predict which offers are most appropriate for customers and the probability of those offers being accepted. So this model can initially be built, with a small data set with some randomly made offers and responses to those offers. And as the data set grows, the model can be updated and therefore becomes more able to predict the most suitable offers for customers and the probability of their acceptance based on, other variables. So with our predictive model defined, we can now integrate our SPSS model with decision optimization. And there are adapters that allow us to bring a modeling stream into an optimization project, which means the predictive values are now available for the formulas in decision optimization. So what we're looking at now is an optimized solution where we're determining the next best offer for each customer based on predicted preference and the objectives and constraints that we've coded into decision optimization. So the decision optimization engine went through our goals and limitations and identified offers that would be best suited for each customer. So for example, while one customer gets a mortgage seminar, another customer will receive a car loan newsletter. And this slide just kind of shows you some of the visualizations and outputs that are possible with Decision Optimization Center, which is an enterprise platform for building and deploying analytical decision support applications. So our solution can now be presented through visualizations and charts and graphs for decision makers. So I really want to reiterate here the synergy between SPSS and decision optimization. So SPSS Modeler together with IBM Decision Optimization really provides a powerful end-to-end decision support system. So SPSS Modeler provides a predictive engine for analyzing patterns to predicting potential future outcomes, and then decision optimization applies mathematical and constraint programming along with the rules to help users find optimal solutions addressing their business needs. So how can you get started? Well, you can visit IBM SPSS Modeler webpage and get started with the product by trying the product, downloading the 30-day free trial. So the modeling workbench that you saw in today's webinar, you have access to the same workbench, and you can play with any data set you want. You can go on Kaggle again and download a data set of your choice, or you can go into Modeler tutorial, which has a lot of cool features such as walking you through hypothetical scenarios with pre-built streams that you can work through, and with data sets that are included with the product, so you can really play around and see how it works. So, if you have a smaller problem that you'd like to solve, you can do that. Also, please join our SPSS Predictive Analytics community. The link is right there, developer.ibm.com/predictive analytics. And there's all kinds of stuff out there right now. We're posting blogs there and events. We have forums. So if you have any questions about the product, if you have any questions, if you want to try other products in the portfolio, SPSS Statistics, that will be the one-stop shop. Come over there and take a look what we have. So with that, I really hope you enjoyed this webinar, and I want to thank you for your attention and for your time, and I want to now pass the torch back to the Data Science Central team.
Mikhail, thank you so much for that excellent presentation. We do have time for today for some questions from our audience. This is Bill Voorhees. I'll be your moderator for the Q&A portion of our presentation. And during the Q&A portion of our presentation, I'm going to leave, beg your pardon. I'm going to leave this slide up, which has Mikhail's contact information on it. So if you'd like to record this, you'll be able to get a hold of Mikhail after the webinar if you have questions for him or the IBM folks directly. So Mikhail, there are a number of questions from our audience that all relate to how SPSS Modeler knows which is the most accurate model and what measures are used to determine that. So for me, what this speaks to is the issue of fitness measures. You know, as a predictive modeler, R-squared, ROC, a confusion matrix, or AIC, BIC criteria. Could you speak to that issue broadly about being able to select criteria and which ones might be selected automatically for us?
Sure. So I can talk to you about just, from a general perspective, if it's a great question. How do you select a different model? And if you're doing this more by hand, you run different models, and then you can set, you have different scores, or you can look at the confusion matrix, and then you can compare and see is one model more accurate than the other model. You can look at the ROC curve and see how your models compare on that. Which one is more, more robust? You can take a look at, sensitivity, specificity, and see how they compare based on those metrics. So by hand, it's going to be really tedious. And, again, if you have a data set, you can apply one algorithm to it and see how it works and play around with your testing and training on that, and, playing around with the parameters and excluding variables. You can add another one. So Modeler does that for you. Now, when it comes to the details and specifics about how specifically Modeler picks out the right algorithms, I think the best place to ask this question, I think, actually would be the predictive analytics community that I mentioned, because it is visited by software engineers and developers and data scientists from IBM who would be able to give a best possible answer to this question.
Thanks. That was a great response. You have focused on an area called prescriptive analytics that is largely based on operations research and optimization methods. Can you speak to the issue of how SPSS Modeler deals with optimization and what variables might be available?
So SPSS Modeler, in terms of how it is made available to the users, comes in different variations, different flavors. So SPSS Modeler, what we're looking at was Modeler Professional. So all kinds of different algorithms dealing with different types of data. The next one would be SPSS Modeler Premium, that allows you to also then do text analytics, social media, social network analysis, entity analytics. Then you have Modeler Gold, and Modeler Gold really it's for the enterprise users. It also includes in it several optimization models that written in CPLEX with CPLEX. So it does have that capability. However, if you want to go beyond a couple of specific models in Modeler Gold, if you want to change them up a little bit, if you want to change the parameters, this is where you can integrate with decision optimization with a CPLEX product. And I think if there are specific questions with regards to CPLEX, again, you can post those questions to the predictive analytics community. I also encourage you to go into IBM.com website and take a look for decision optimization and post your question there. Additionally, just recently a new product was just launched in the decision optimization family, IBM Decision Optimization on the cloud, so you can look at that and take a look. There is a trial available, and you can post questions to those folks who would be able to give the best answer, I think, with regards to decision optimization.
Oh, thank you. Thank you very much, Mikhail. A lot has been said these days about unstructured and semi-structured data and Hadoop, HDFS, Hadoop file system structured data. Can you tell us about the parts of SPSS Modeler that will work with semi-structured or unstructured HDFS data?
So that's a great question. Modeler will work with that data, absolutely. So if the audience remembers, we were looking at the Modeler workbench, and we're looking at the bottom of the palettes with the different node types. One of the source nodes said Analytics Server. So this piece, this product analytics server, allows you to pull data out of and put it then back into Hadoop.
Terrific.
So absolutely. So you can absolutely use that.
All right, and I heard you speak to the issue of text analytics, as well as, I presume, semi-structured JSON and XML data. There is a question here, and I think I know the answer to this, but I should let you respond directly. Is SPSS open source?
SPSS is not open source. However, SPSS works with open source languages such as Python and R, embracing the open source culture. And I mentioned the webinar that should be available, I think, on Data Science Central for replay about the 7 business case, 7 reasons to use SPSS together with R. So I think listening to that webinar would be really helpful in answering this question, or adding more color to it, and that SPSS together with R, together with Python, can have synergistic outcomes for the organization. So.
Thank you. Yeah, excellent answer. And by the way, I did personally listen to that May 26th webinar and found it very valuable. So I also encourage our audience to watch it that has more interest. And since we're kind of on the topic of R, let me kind of combine a couple of questions here that I see on our screen. Now, SPSS Statistics and Modeler work with R. Are they also generating R code?
They do not generate R code. What you can do is for example, with Modeler, if you want to do something, if you have some kind of a custom algorithm that is not natively available in Modeler, and you want that algorithm be part of your model, you can write the code in R, or if you go again to our predictive analytics community, we have already extensions in R that you can easily download and integrate with your Modeler environment that will be, coded in R, and you can really easily use them in your model.
Excellent. Yeah, rather what I thought. Well, thank you for that response. Some of the folks on our webinar today are clearly pretty sophisticated data modelers. Here's a couple of questions I'd like to synthesize, and it's about how SPSS Modeler treats missing values, and let me also toss into that, how do you handle outliers and imputes?
Good question. There's different ways for you to handle missing values. You can, so in the Modeler stream, in the Modeler plet, there's an option for auto data prep nodes. So that auto data prep node can help you automatically pre-process the data. It can normalize it. It can take care of missing values. Additionally, if you saw me do when I generated the star-looking thing in the workbench, that was the missing value super node. So Modeler allows you to impute missing values, with, in this case, it was a CRT algorithm. Also, you can impute missing values. You can use a mean of the variable you're trying to predict. You can use a mean by a certain class, or you can use a certain fixed number. You can write your own function. If you want to do that, you can derive one variable from another variable. So there's different ways of how you can handle missing values. Same thing goes with how you want to handle outliers, whether you want to bin your data, whether you want to, beforehand you want to do a clustering on your data to kind of take care of missing values. That'll depend, I guess, more on, your approach to handling them, to handling that issue.
Yeah, I realize that's a very personal decision for practitioners to make, and it's always important to understand what the assumptions are in the tool that you're using.
Correct.
And I'm sure that SPS offers a broad range of options.
Absolutely.
Here's a question from our audience, and let me ask this question two ways. First of all, does IBM offer SPSS on the cloud? And secondly, can SPSS be implemented via the cloud?
So IBM SPSS Modeler Gold, which I previously mentioned, is available. It can be deployed on the cloud. So there's an option to do that if you want. With regards to being deployed on other cloud, that I would post to the Predictive Analytics community and see if someone would be able to give an answer to that, just to be sure.
Good. Well, thanks very much. Some more specific questions from the clearly the predictive modelers in our crowd. In what ways can you specify transformations on specific variables in Modeler?
Well, you can obviously you could normalize your data. You can bin it. You can what I would encourage everyone to do is download the free trial and take a look at it for yourself and see what would work best for you. Download the SPSS Statistics trial and see how that works for you as well. See how they work in tandem, because they're really synergistic products. But there's multiple options for you to transform your data, and again, it'll depend on what you're trying to do.
Great. And some of our folks have asked how much, or by exception, how little data do I need to get started with SPSS Modeler in order to get an actionable result?
That's a great question. Sometimes there's a notion that you need to have a data warehouse before you can start doing predictive analytics, and that's not true. You can start. Really, it's a good idea to get started with. Obviously, if you have a data set with 10 variables and 10 rows, 10 records, not much. You're probably not going to get much good insight from that. But if you have some data, you can get started. And really building on small wins. You have a small project, a small problem, and tackling that will help you gain consensus in the organization and buy-in, and then be able to tackle larger problems. So really, you can start with, when you don't have too much data, it's okay to start out and see how that works for you, how it works for your problem. Again, in some instances, in some point, it's going to depend also on the business problem that you have at hand, because the number of rows is going to be, it's more subjective.
Yeah. Well, Mikhail, hey, thank you so much for those great answers to some very good questions from our audience. I'm going to move now into just some brief announcements as we wrap up. And for those of you that had asked questions today that weren't answered, rest assured you'll receive an answer, as we'll be sending all of the unanswered questions to Mikhail and his team at IBM, and they'll make sure to follow up with you directly today after today's seminar. Just a few quick announcements. Please mark your calendar for June 9th and our next Data Science Central webinar event, which is All Recipes, Growing the World's Largest Digital Food Brand Through Data Visualization. And that's going to be sponsored by Tableau. And by the way, there was an additional question about where you could see today's webinar. It'll be posted later today on the Data Science Central website. If you look at the top of that site, you'll see a tab called Webinars. And if you look in there, you'll be able to find later this afternoon both today's webinar, and if you care, you can also look back at the May 26th IBM SPSS webinar that was also very good. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thank you again to IBM for their sponsorship and our panelist, Mikhail Lakirovich, for his insight into today's topic. On behalf of Tim Matteson and myself, Bill Voorhees, we're very pleased to have been your host today for today's event, and we look forward to seeing you again on June 9th. Good day.